welfare maximization. So there are two things which we need to worry about under welfare maximization, that the maximum social welfare function must be Pareto optimal allocation. And the second one is that any Pareto efficient allocation must be welfare maximizing for some social welfare function. So in this recording, we're going to talk about the first one first, right? So there are, let us say, n individuals. There are n individuals. There are k goods, right? And so if you talk about xij, means ith individual consuming jth good. So when you say allocation x, right? So this will be on different individuals, x1, x2, and so on to xn. How do you write x1? So individual 1 is consuming first good, individual 1 consuming second good, so on to individual 1 consuming kth good, like this. Similarly, how do you write for x2? Individual 2 consuming first good, individual 2 consuming second good, and so on to individual 2 consuming kth good, and so on to, for xn, individual n consuming first good, individual n consuming second good, and so on to individual n consuming the kth good, like this. So this is an allocation. So feasible allocation would be, so how do you write this? That is feasible allocation. So you would say that the total of good one with all the individuals should be equal to the total supply of good one. That's what it is. So I1, I starting from 1 to 1. So X11 is the amount of good one with, I mean, whatever he is demanding for amount of good one, individual one is demanding. X21 is amount of good two, sorry, amount of good one, individual two is demanding. Xn1 is amount of good one, individual n is demanding, right? So this is the total of good one with all individuals should be equal to x1 bar, right? That is total supply. Similarly, you can write for the kth good also, xik, right? For the kth good also. So what you are trying to find out is, our objective is that we will try to find out such a feasible allocation which is going to maximize the social welfare, right? Such a feasible allocation that maximizes social welfare. right? So what are the properties which such an allocation should have? What properties does such an allocation have? Does such an allocation have? Well, we are talking about the first property. There are two such properties. We're talking about the first property in this. So the first one is the maximal social welfare. The maximal social welfare allocation must be Pareto optimal allocation. Must be Pareto optimal allocation, right? So let us say it is not. So we are saying that wherever social welfare is going to be maximized at that particular point, that such an allocation will be a Pareto efficient allocation. So let us prove this by contradiction, that suppose it is not a Pareto optimal allocation. There's a proof by contradiction. Suppose X star is a social welfare maximizing allocation, but it is not Pareto optimal. But it is not Pareto optimal. So if it is not Pareto optimal, then there would exist some other allocation, let us say X hat, which is providing the same utility, maybe same utility to everyone, and to at least one individual, it is strictly providing a higher utility, right? So then if this is not a Pareto optimal allocation, then there exists X hat, a Pareto efficient allocation, such that everyone in that allocation may be having the same utility as X star, what X star was providing, but at least one individual is having the higher utility than X star. It offers everyone a same utility and one person a higher utility, right? At least one person a higher utility. So if at least one person is also getting a higher utility, then the utility which you are getting from X hat would be more than the utility which you are getting from X star. So that would mean the welfare or utility which you're getting from X hat is more than the utility which you're getting from X star. So the social welfare which is associated associated with X hat is more than the social welfare which is associated with X star, then how can X star be a social welfare maximizing? It cannot be, right? So if social welfare associated with X hat is higher, it means X star is not a point of maxima, right? So if X star is not a point of maxima, then how can you assume this, that X star is social welfare maximizing? It is not. So this is a contradiction. This is a contradiction, right, beta? So you cannot have something which is maximizing social welfare, but it is not Pareto. So that's an idea here. So that's a contradiction. So you cannot say that X star is social welfare maximizing, but it is not Pareto optimal, because the moment you say that it is not Pareto optimal, it means that there exists some other allocation which is providing you a better utility. At least one person's utility could be better. So if that is the case, then X star itself is not welfare maximizing, right? It cannot be. But if X star is not welfare maximizing, then why have you supposed this? So that's a contradiction. Hence, social welfare maximizing allocation X star is also Pareto efficient. X star is also Pareto efficient. Okay. Let us also look at this kind of a diagram. So you have an Edgeworth box diagram. Here you have individual A, here you have individual B, and these are the Pareto optimal allocations. And how do I know that these are Pareto optimal allocations? So these are the indifference curves of the two individuals. They're tangent to each other at these points, right? So let us say this point is A, this point is B, this point is C, this point is D, right? This point is D. And let me just write this as UA1. How should I write this? I should not be writing UA1. I should be rather writing U1A, U1B, U1C, U1D. Like this. Similarly here. So you can write it like this. This is the utility which individual 2 get at A, utility which individual 2 get at B, utility which individual 2 get at C, utility which individual 2 get at D, like this, right? So at point A, individual 1 is getting U1A, and at point A, individual 2 is getting U2A, right? So if I have UA and UB out here, UA and UB out here. So here, let us say we have point A. Utility of individual A is little less, but utility of individual B is very high. This is one point. right? Similarly, you have point B. Here now, utility of individual, I should not be writing UA, UB, U1, U2. So sorry. So utility of individual 1 at point B is little higher, but utility of individual 2 has now decreased. C, D, and so on. So what you have done is that you have traced out all the points, all the what you have traced out is the utilities which individuals are getting at these Pareto efficient points, right? So, and this is what is called the utility possibility frontier or UPF, right? So what is this telling you? It is telling you the utilities which are associated with different Pareto efficient points, right? It shows utilities associated with different Pareto efficient points. So what you're going to do is, of course, all of these are different Pareto efficient points. So you're going to pick up one such point which is going to maximize the social welfare. For that, we need another tool which is called an ISO welfare function. It's like your utility function only. So, or indifference curve only. So what is indifference curve telling you? Indifference curve is telling you that different combinations of the goods are providing the same utility to you. Here, ISO welfare function will tell you what? Right. So you have individual 1 and individual 2. So these are each curve. So it is the same welfare along the curve, both the individuals. So maybe here, individual 1's utility is less, but individual 2's utility is more. But the society is having the same welfare this way. And if you go on to the higher ISO welfare curve, it is represented with a higher welfare, right? So each curve is representing a different welfare, and what it's something like just your indifference curve. So a higher welfare is represented with an outward curve like this, right? Well, so you have the, okay, I'll draw a different diagram. So you have U1, U2, you have this UPF, this is the boundary of UPF. And these are different ISO welfare curves. These are different ISO welfare curves, like this. So at this particular point, welfare is maximized. This is the welfare maximization, right? So this optimal point is characterized by what? Tangency between the ISO welfare function and the utility possibility factor, right? And the other thing is that this point is also Pareto efficient. This is the maximum point of the social welfare, So this point is also telling you some kind of social welfare, but social welfare is not maximized out here. So this is the point of the welfare maximization, and this is also the Pareto efficient point. So the maximum social welfare is a Pareto efficient point. So, and it must occur on the boundary of UPF. It must occur on the boundary of UPF, right, beta? So for such kind of ISO welfare function, you have this point as the welfare maximization, and this point is also Pareto optimal, right? It must occur. You know this, I mean, for example, if you want to maximize your utility, you should be spending your entire budget, right? So, I mean, it happens on the budget, right? On the budget line. So this is the same thing on the boundary of UPF, right? So this is the boundary of UPF. However, okay. So this entire thing is a set, and this is the boundary of UPF. Okay. So this is the first property of the social welfare function. Achha, the other thing is, if you have a different kind of the ISO welfare function, you may have a different point of social welfare on this, right? So any Pareto efficient allocation can be welfare maximizing for some social welfare function. That's a second property. That's what we're going to do in the next class. Thank you, Beta.